Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from electrostatic chapter. Okay. So our first question is: two charged spherical conductors of radii R1 and R2 are connected by a wire. Then the ratio of surface charge densities of the spheres sigma 1 by sigma 2 is. Okay. So now let us see what he gave. He told that he took two spherical conductors of radius R1 and R2. Okay. And he told that he connected these two spherical conductors by a wire. And he is asking us to calculate the ratio of surface charge densities, that is sigma 1 by sigma 2 after connecting by wire. Okay. That is sigma 1 by sigma 2 is how much? Okay. So before going to the solution, let us discuss about the potential on a spherical conductor. The formula is V is equal to 1 by 4 pi epsilon naught into Q by R. Okay, where R is the radius of the sphere, Q is the charge on the spherical conductor. Okay, now if you take sigma as the surface charge density, that is sigma is equal to Q by 4 pi R square. Okay, then Q can be written as sigma into 4 pi R square. Okay, then if I substitute that Q here, then what will I get? V is equal to 1 by 4 pi epsilon naught into Q. Instead of Q, I can write sigma into 4 pi R square. Sigma into 4 pi R square by R. This R will get cancelled. Then if you take this entire this 4 pi, this 4 pi will get cancelled. Okay, and if you then what can we write? We can write the formula for potential as some constant k into sigma into r. Okay, so this is the formula for potential on a spherical conductor in terms of surface charge density and radius. Okay, now what did he give? He told that he took two spherical conductors and connected by a wire. He connected these two spherical conductors by a wire. Okay, initially the charge, that is before connecting with wire, the charges on the spherical conductor may be equal or may not be equal. But when we connect these two spherical conductors by wire, what happens is charge will flow from higher potential to lower potential. The potentials of these two are equal. Okay, that is the potential due to spherical conductor V1 is equal to the potential due to spherical conductor V2. Okay, we can write potential as A into sigma R. Okay, then now if we substitute A into sigma 1 R1, where sigma 1 is the surface charge density of first spherical conductor, R1 is the radius of the first spherical conductor, that is equal to K into sigma 2 R2. Okay, this will get cancelled. Then sigma 1 by sigma 2 will be equal to R2 by R1. Okay, so the answer is first option. Now let us move to our next question. Our next question is: a parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plates is D and the area of each plate is A, the energy stored in the capacitor is. Okay, now what he is asking? He is asking us to calculate the energy stored in the capacitor. Okay, now what did he say? He said that you have a parallel plate capacitor and the value of uniform electric field present between the plates is E. Okay, and he told that the distance between the plates is D. Distance between the plates is D and area of each plate is A. Okay, he asked us to calculate the energy stored in the capacitor. Okay, we know that the formula for energy density is half epsilon naught E square. Okay, where epsilon naught is the permittivity of free space, E is the uniform electric field present between the two plates. Now this energy density can be written as energy by volume, that is equal to half epsilon naught E square. Okay, that implies energy can be written as energy E is equal to half epsilon naught E square into volume of the parallel plate capacitor. Okay, volume of the parallel plate capacitor can be written as V is equal to effective area A into distance between the two plates. Okay, effective area A means effective area between the two plates, A into distance between the two plates. That implies I can write like this, that is half epsilon naught E square A into D. Okay, the equivalent capacitance of the combination shown in the figure is, okay, so he gave three capacitors which are connected like this, and he is asking us to calculate the equivalent capacitance between A and B. Okay, now let us go from this side. This point is connected to this point by a wire. Okay, since there is no any resistive element or any element between these 2 points, that is the potential across this point will be equal to potential across this point. Similarly, since there is no element, any capacitor, inductor or resistor between this point and this point, that means the potential at this point will be equal to potential at this point. Okay, so if I take the potential at this point as VB, then the potential here will be VB, the potential here will be VB. Similarly, the potential here will also be VB. That means this capacitor is subjected to same potential on each plate, on both plates. That means this capacitor will be ineffective. Okay. Finally, what will, so there is, this capacitor is ineffective and we should not assume this capacitor. So finally, we will be left with two capacitors between A and B which are parallel. Okay. In the case of parallel combination, the formula for effective capacitance is C effective is equal to C1 plus C2. Okay. And he told that, and he gave that the capacitance of these two capacitors are equal. That is C. That implies C plus C. That is equal to 2C. Now let us move to our next question. A dipole is placed in an electric field as shown. In which direction will it move? Okay, what did he give? He told that this is electric field and in this electric field he placed a dipole. Now he is asking us to calculate the direction in which it moves. That is whether it moves towards right or whether it moves towards left. Okay, now what is dipole? Dipole means two equal and opposite charges separated by certain distance is called as dipole. Okay, that's one thing. And it is clear that the field that is that this dipole is subjected is non-uniform electric field. Okay, so if you see here, within, if you compare the field here that is near to positive charge and field near to negative charge, these three electric lines of force are passing through small area compared to here. That is, the electric lines of force are clouded at plus Q compared to minus Q. That means the intensity of electric field at plus Q will be greater than the intensity of electric field at minus Q. That means the field here, E value here at plus Q will be greater. That means plus Q will be subjected to more force compared to minus Q. That means the force on plus Q which is towards right is greater than the force on minus Q which is towards left. Okay, that is, this force is more, that is force towards right is more compared to force towards left. That means on a whole the net resultant force will be towards right. Okay, the net resultant force on the dipole will be towards right. That means this dipole will move towards right. Okay, now since this dipole is subjected to some net resultant force towards right, that means it is being accelerated towards right. That means its velocity will increase towards right. That is, its kinetic energy will increase towards right. Since its kinetic energy is increasing towards right, then what happens? Its potential energy will decrease towards right. Okay, so finally we came to a conclusion that this dipole will move towards right and the value of potential will decrease as the dipole moves towards right. Okay, So the answer for this is first option. That is, the dipole will move towards right as the potential energy decreases. Now let us move to our next question. What did he give? Polar molecules are the molecules. Okay. What are polar molecules? Polar molecules are the molecules in which the center of positive charge will not coincide with the center of negative charge. Okay. Since the center of positive charge doesn't coincide with the center of negative charge, what happens is they will have a permanent dipole moment, though they are not placed in any field. Okay, now let us move to our next question. 27 drops of same size are charged at 220 volts each. They combine to form a bigger drop. Calculate the potential of the bigger drop. Okay, so what did he give? He told that he took 27 charges and the 27 what you call drops. Okay, 27 drops, and the potential on each drop V is equal to, which is a spherical drop, 1 by 4 pi epsilon naught into Q by R is equal to 220 volts. And what did he say? He combined these 27 drops into a bigger drop, and he is asking us to calculate the potential of the bigger drop. Okay, first let us see whether these small drops have same charge or not. Okay, what did he give? He told that these drops have same size. That means their radius are, okay, are equal. Okay, the radius are equal. Now potential V is equal to 1 by 4 pi epsilon naught Q by R. V depends upon Q and R. Now he gave that the potential of each drop is 220 volts. Okay, so potential is constant and its same size. That means its radius is also constant. Then charge should also be same. That means the charge of these two 27 drops are equal. Let me take it as Q. Okay. Now what did he say? He told that he combined these 27 drops into a bigger drop. Okay. Then what will happen? The charge on the bigger drop will be Q dash is equal to 27 times that of charge on each small drop. Okay. Then now let us think in terms of volume. The volume of the bigger drop V dash will be equal to 27 times that of volume of small drop. Okay, let me take the radius of bigger drop as R dash. Okay, then V dash, since it is a spherical, V dash can be written as 4 by 3 pi R dash cube is equal to 27 times that of 4 by 3 pi R cube. Okay, this will get cancelled. Finally, what will get? R dash is, that is the radius of the bigger drop is 3 times that of radius of small drop. Okay, now what did he ask us to calculate? He asked us to calculate the potential of the bigger drop. Okay, the formula for potential of the bigger drop is V is equal to 1 by 4 pi epsilon naught into Q dash by R dash. Okay, that is equal to 1 by 4 pi epsilon naught. Q dash can be written as 27Q by R dash. R dash can be written as 3R. Okay, this will get cancelled 9 times. That implies this can be written as 9 into 1 by 4 pi epsilon naught into Q by R. Okay, Q by R. This 1 by 4 pi epsilon Q by R he gave as 220 volts, which is nothing but the potential due to small drop. Okay, that implies the potential on the bigger drop V is equal to 9 into 220 volts. That is equal to 1980 volts. Okay, so the potential of this bigger drop is 1980 volts. If you feel that this video is useful, kindly share to your friends. Okay, if you have any doubts or suggestions, you can comment me in the comment section. If you had not subscribed till now, kindly subscribe to my channel. The only thing that I expect from you is a single like, because your single like and comment will encourage me for making better videos. Thank you.